Let's talk about AI image generation, one of the cooler functionalities of AI. There's roughly 80 million AI images that are generated every day across the major platforms these days, so it's certainly a function that's being used a lot, and it's only going to get better. Now, the first thing to understand is, what does an image actually look like to a computer? So let's say we're seeing a photograph of a sunrise or a sunset. What the computer is seeing is just a grid of numbers. Every single pixel carries values describing how much red, green, and blue it holds, and the single high-resolution image we're seeing is just millions of these pixels. So if you remember back to episode 3, we said a large language model has to predict one token at a time, choosing between a few options to decide what the next most likely word is going to be, or whatever the next piece is going to be. An image model has to produce millions of numbers that all agree with each other for that image to make sense. So it actually helps to think of it as removal rather than drawing. So if you think of a picture, let's say of a dog on a beach, and then you sprinkle a bit of static over it. Now the dog is still pretty obvious, and then let's say you put more on it. Now it's starting to get kind of grainy. And then afterwards, as you keep going and you keep doing that, everything just becomes pure noise. And that's what the forward process is. It's deliberately destructive. So when they're training a diffusion model, that means doing this to billions of images at every level of damage. And then you're just asking the model one thing. Given all this noise and waste, which part of it is the actual substance? If you think back to episode 2, we said that learning for a machine is basically making a guess, measuring how wrong it was compared to the correct answer, and then nudging its internal weights or settings to guess next time a bit better. And that's effectively what its training is. Now, if you point that exact same loop at these images, it can guess the static. And as it does that, the system already knows the exact amount of static that it added because it's the one who added it. And the gap between what was already there and what the system added is where the learning happens. And if you do this enough times, you can hand the model a half-ruined picture, and it can reliably spot where that substance is and what actually belongs. Now that's how the model learns and works, but how do you actually prompt it to get exactly what you want? For this, you need a text encoder. The most famous model is called CLIP, and it was trained on hundreds of millions of images and caption pairs, and it basically learned to place a photograph of a sunset with the words or prompt saying a photograph of a sunset. And these texts and these pictures ended up sharing one coordinate system. So when you prompt these image models, your prompt basically becomes coordinates, and those coordinates get fed into that noise remover at every round of cleaning until it takes away more and more to give you the final product, which is actually related to your prompt. Now, as you can imagine, a million pixel image running through the model dozens of times is going to be way too expensive. And that's why Stable Diffusion was introduced in 2022, also known as latent diffusion. So before any cleaning happens, images are compressed by a small network into a shorthand sketch or a rough copy that basically keeps the meaningful structure, and it gets rid of all the fine details. And then all that noise, the cleaning, the prompt steering are going to happen on that rough sketch, and then only at the end, the decoder is going to expand it back into a proper picture. Now, something else you might have noticed is that you might have the same prompt, but it's not giving you the same picture. And the reason for that is the static that the model is starting from is randomly generated, and that starting pattern is called the seed. So when you have a different seed for each time you prompt, there's a different starting mess, there's a different picture, even with an identical prompt. Now, diffusion isn't the only way that these pictures are made. Now there's alternatives where we can treat the picture the way we treat a sentence. So the image can be broken down into visual tokens, which are just small patches of the image, the way usual tokens are just small pieces of text. And then they can be predicted in sequence one after the other, just like we do with word prediction. Now, inpainting is when you select a part of an image and ask for it to change. So the model is only going to add noise to that region while holding everything else fixed. And then it's going to clean it back with your prompt steering and the surrounding image as context. That's how you remove a lamp or a background gets swapped, for example. And then outpainting similarly is just extending the frame by cleaning the noise in the empty space around an existing picture. So that's pretty much it for this one, you guys. That was image generation explained in very layman terms. Be sure to check out the newsletter and the resources in the description. We're working on a free community and other cool stuff there. You can find us on any podcast platforms. Let us know what you want to hear about next, and we'll see you next time. Cheers.